data?
Yes, okay.
Yeah, it's okay. No problems with the projects. You have already collected your data and you're ready for analysis.
Yes, inshallah.
Today we will start with the analysis, inshallah.
So, Mr. You gonna take exam after the class?
Yes, after the class.
Okay.
Are you going to attempt the exam?
Yes,
Did you book?
I
Did you
will,
book?
Mr. But on the Google spreadsheet, we wrote our names, but Med19B or who I don't know, they erased our name and they wrote their own names. And now I cannot find my name.
That is strange.
Actually, I was first in the list.
That is strange.
Yes.
Why does somebody do this?
I don't know. It's very unfair.
Did you notify Dr. Azamat about it? Dr. Azamat, did you know that some names are
Yes.
erased?
Yes, I know
Yes.
that. I disabled
Yes,
the
I told
edit
him.
option.
That's interesting.
Sir, Mr. Azamat, I have the old list. I'll send you in WhatsApp the old list where our name was there.
Okay.
Let me start. And I don't know, I'm not sure what I should do with the new students. Would anybody like to speak up and say something to the new colleagues? I have to welcome them, of course. So welcome new colleagues. Any of the new ones would like to introduce himself, herself, or say something? Ask something maybe? Anyone here? Dr. Azamat, I'm really confused. I don't know what I should do with the new ones. Yeah, no, which topic?
Sampling.
Some sampling, and now let me see the course names.
We have all the lectures recorded. They can go back and
they can watch them, huh?
watch them.
Okay. So then we have lecture 15 and 16. Now they have to watch 14 more. And we have to conduct some exam to them, I think. That we have to discuss with the management. Anyways. Okay, welcome. That's all what I can say now, right now. Now, so far we discussed, last time we discussed the theory distributions. And now it's time to mention about sampling. Today we will discuss sampling distributions, and then confidence intervals. What are the confidence intervals? When I say sampling, actually, I know that in your life, you always have sampling. Is there anybody who is dealing with agriculture in the class? Farmers, farmer kids? Do you have farmer kids here in the class? Anybody farming? No?
Me. I don't farm, but I like to plant.
What kind of goods do you produce? Face?
Flowers.
Flowers.
Yeah.
Yeah. So if you are farmers, you produce, for example, flowers. Let's say you produce flowers. You have a field of flowers.
Yes.
A big field produce flowers. You have here so many flowers. Let's say these are all flowers. How many flowers
Yes.
do you have in your field?
I have like 25 list.
Many flowers in a field. It's a field. Let's say this is a 1 hectare area.
Yeah.
You have let's say 10,000, 20,000 flowers here.
Oh no, that's a lot. I have like
That,
just a small, but
yeah.
yes.
Yeah, there will be thousands of flowers.
Yes.
Flower field, huh? Field. A field of flowers. So
Yes.
if a customer comes, if somebody wants to wool, buy all the flowers, he looks to the field, he looks at it, and he wants to give you a price. You want to bargain with him. You want to tell him, okay, I have a field here with 10,000 flowers, approximately 10,000 flowers. This is N, big N, approximately 10,000, let's say. And he has to give you a price for it. What he will do, he has to see, of course, what is the quality of the flowers. Are they long? Are they tall, small? What is the quality of the flowers? Maybe he will produce some oil from them. He needs to know the yield. What is the yield? So there will be many questions in his mind. The quality, sorry, the yield, the nutrient content, let's say, nutrient, what is the color, so many other things he wants to know. But you have in your field 10,000 flowers. It is impossible to go and check one by one all of them and then give you a price. What he does, he picks up some flowers from here, some from here. He makes a random sampling. Does he? That's the only way. He has to cut some flowers, maybe 5, 10, 20, as many as he feels it is enough. And then he decides. He inspects these flowers. Maybe he takes out from the field 10 flowers, 20 flowers, 50 flowers, but not 10,000 certainly. And on behalf of this sample, he gives you a price, or he bargains with you. It is similar in everything. For example, I am from the Black Sea. We have there, we are growing nuts. You know nuts, hazelnuts, small nuts.
Yes.
And if you have 1 ton, 2 tons, 3 tons, 5 tons of nuts, and you want to sell it, the buyer has to give you a price. You cannot crush all the nuts, all the millions of small nuts, and inspect them and give you a price. He has to do a sampling. Okay, this we call the sampling. If you have a large population, you have a population. You have a population of this we call the N, big N. It is X. It is, let's say, a city, a village of people, a hospital with the hospital workers, whatever you call the population, you can define it. The population can be the students at the Alatu University, the the citizens in a village, the citizens in a city, the patients in a hospital. And then among these n, how many they are, you do a sampling. You sample some of them. Okay? This we call the sample. You take them out and you analyze them. Sample. So there is a population. From the population, you take a sample, n. Okay? This big N can be, it's a large number, of course. If it is a village, it can be 2,000, 3,000 people. And the sample can be smaller, let's say 50 people, 100 people, 200 people. Okay? Let's read from the book. Let's refer to our book and see what the book says to us. Any questions so far? So why do we sample? The reason we sample is because the population is so big, as I mentioned in the example of the flowers in the field. The population is so big, it's not possible for you, it's not convenient for you, it's not efficient for you to investigate or to sample all the individuals. Therefore, you do a sampling. You take some cases from the population. There is a population which represents the entire group, and from the population, you collect a sample, some individuals, which you believe are representative of this population. So the key point here is it has to be representative. Your sample has to be representative of the population. For example, you are in your class, in the Alatu medical students. Let's say our sample is the Alatu medical students. Alatu medical students. Let me delete this. Where's my... Okay. Sorry. Let's say our population is Alatu medical students. How many students are there in class 2? Alatu, class 2, medical students, class 2. How many students we have in this class? This is shown with the big N.
42?
42, let's say. Yeah? You are 42. 42 is
I'm not sure, but it's like 42. No.
Yeah, it's not very big, 42. Okay, that's not a good example for us. The population should usually the population is much larger, like 400.
Group together 90. Maybe we can add Med-19B and Med-19A.
Yeah, if you have only 42 students, it is of course easy to access all of them and sample all your population. But usually we have a larger sample of students, let's say 420, and then it will not be possible to sample all of them. Therefore, you do a sampling. The sample has to be what? It has to be representative. Representative. What I mean by representative? How, if I have 420 students and I want to make a sampling, okay? How can I do? what kind of sampling I can do here. There are different kinds of samplings. Like one most important rule, it has to be random sample. If I ask one of you, let's say Beyzanur, go and take me, I calculated that I need for this sample, I need, let's say, 20 students. And I ask Beyzanur or Begimay or any of you, any Can and Ayhan, any of you, I ask, go and take me 20 students. I will measure their weight, their height, or anything. I will do a study on them. How they are going to go?
Biostat state नहीं होती biostat study होगी किताब वो तो ठीक है लिख दे के चला करा है कंप्यूटर
He has his microphone on.
नोटबुक तो लिखना सामने बुलाया ठीक है population
Tatir Nasir, can you switch off your microphone? If you are talking to us.
Probably not. I turn off his microphone.
Okay, thank you. So, if I ask you to go and take out of 420 students, if I ask you to take 20, and Beyzanur goes and she samples her friends, because that will be easier for her. That would not be a good way to collect this data. It should be a random sample. Random sampling. How can you do a random sampling? You either have a list of all individuals from the population, all individuals, and then you draw by chance. You just throw a dice, or you have a random numbers lists, or you use a computer to select the individuals. I will select out of these 420, I will select 20, but these 20 will be the first one, the 15th one, the 120th one, the 415th one, etc. It will be a random sampling. So it has to be random. Random. That's very important. It has to be representative and random, this sample. Okay? And we have to know the amount. How many people? So the question is, if you are doing sampling, you have to know how many people I need. Then you have to have a representative. It has to be representative. And you have to do it on a random way. But sometimes, just because if we don't have a time or we are not able to conduct a random sampling, we do also convenience sample. Convenience sample means it is on, you do the sampling on your convenience. You just go and pick up the first 20 students you meet in the class, or you just collect data from your own friends. That will be biased, of course. Convenience sample is a biased sampling, okay? We can do it convenience sample. Convenience. This is, if I ask you about convenience sample, you will say it is not advised. No? It is done in science, convenience sampling, but it is not a good way to sample. It is biased. You should not, if possible, you should never do a convenience sample. You should do a random sampling. Okay. There are other methods of sampling too, like the quota sampling. Quota, for example, the quota sampling. Okay. This is used in polls, usually in polls. You know, when it's time for the elections, for the national elections of the parties, political parties, there are many polls appearing in the newspapers. They say that this party will receive 20% of the votes, the other party will receive 30-35% of the votes, etc. So how they are going to conduct these polls? Because they need results very fast. In a few days, they have to present to the readers, to their readers, these newspapers, especially some data. So what they do, they assign some quota to each city according to the size of the city, and then ask the individual who is going to collect the data just to reach a quota. For example, they tell you, Ermek, go to Bishkek and ask 100 people on the street about whom they are going to vote. Introduce them this questionnaire. And it doesn't matter who these 100 people are. You can go anywhere on the street and approach the people. This is a quota. But usually it's advised to have a random and systematic sampling. Systematic means there is a system, there is a rule. For example, every nth person. If I say to you, what is systematic sampling, you can give the example. I am seeing patients in my polyclinic, in my outpatient, and I take every second patient, every 10th patient, and ask him to fill out a questionnaire. This will be systematic. If you have a class of 420 students and you want to collect 42 students out of 420, what would be the systematic way? You take every 10th student and ask him to participate. That would be a systematic sampling. And of course, it has to be systematic and random. Don't forget, always it has to be random. Yeah, and representing the population, I said already, it has to represent the population. There are many other methods of sampling. These are methods of sampling. For example, the snowball method. Or what else? There is the square root. These methods are also frequently used, and I may, in the exam, I may ask you to describe what they are. What is a snowball method? You know the snowball, it is small in the beginning and then it grows as you roll it, huh? A snowball. It grows as you roll it. So in a snowball method, you find some index cases, some index persons. These index persons are usually people difficult to approach. For example, in a population, if you want to do a study on AIDS people infected with AIDS, it is not easy to find the people with AIDS or hepatitis or gay people, lesbian people, or people with some who are discriminated in the population, like in a Muslim community, if you want to approach and ask questions to communists, or in a socialist community, you go and you want to approach and you want to ask questions to a study on Muslims. That these people are difficult to find. Huh? If it is difficult to find the people, but you know they are like drug users, okay, like minorities, as I said, okay. But if you find an index drug user, somebody who takes heroin, let's say, and you ask him, you convince him to help you with the study, and you ask him to go and find some other colleagues. You yourself, you are not possible. It's not possible for you to find the other similar cases. But this drug dealer, he knows some other people, so he can introduce you to others, and these others, they can introduce you to even more people and even more, and so you can reach your sample. It is the same for other minorities. If you are in a community where only few Muslims are living and you want to make a study on Muslims, you just find one Muslim and you ask him, are there any other people I can do the study, and then he may help you. Okay? So this is a snowball. When I ask you about snowball, you will mention it is done in groups where it is difficult to find the sample, such as minorities, and the index persons, they help you to roll up your snowball and increase the sample size. Another interesting sampling method is the square root sampling. Maybe you have witnessed when you are in an airport and you go through the X-ray or you go through the security control. They don't stop some people. They don't stop the person in front of you, but when it is your turn, he stops you. And then maybe you decide, you think, oh, why this guy always stopping me? Is he discriminating me? Is he a psychopath, or why they are always stopping me? Or you see in the newspapers that in the USA, for example, they usually they stop the black people and they search them. Or in the UK, I have read in the newspapers, they are stopping and searching the foreigners more frequently. Why they do this? Because there are the security risk is different in the community. The security risk of profiles. There are some profiles where the risk of getting a case is different. This is by experience. The security guard over there, he has worked there, let's say, tens of years. And during his time, he has seen that those who smuggle some forbidden items into the country, they have some profiles. Their color or their religion or their country of origin is different. So what they do, they have to search these people more frequently than the others. And then this William Press is his name. He introduced the method of square root. He says, if a group is n times as likely as average to be a security risk, the person from that group to be searched is square root n times likely to be screened. So when 9 people go through from the population, go through an X-ray search, and the square root would be 3. That means of these 9, 3 should be screened. That's a method introduced first in the airports, but later it is also used in other scientific studies. Okay, I couldn't use the time efficiently this time. Yeah, that much about the sampling. And then From our sample, somebody asking you something? No. Okay. The reason we sample is very simple. We sample because it is, as I said in the beginning, it is not possible to reach all the population, all the members in the population. After we sample, we have to calculate, of course, we have to do our estimates. We are behind to estimate the population, the values of a parameter in the population, a parameter that we call, if it is in the population. So we do a sample statistics, or it may be a point estimate, like a single value, the mean of the population, or an interval estimate, like the standard deviation, which we will discuss next session. So why do we sample? From the sample, after having our sample, however whatever method we introduce, from the sample, we do either a point estimate, which is the mean, for example, the mean, or the interval estimate, which is the confidence interval, CI, confidence interval, as an example. Yeah, and of course, if you have done a sampling, if you didn't measure all the population, you have a variation. It is not 100% correct. There will be a possibility of making error. So therefore, we have to calculate the variation in our sample, and this we do by calculating the standard error of the mean. The standard error of the mean. Okay, the standard error of the mean is very important in statistical calculations, and this formula you should know how it is done. It is normally, if you know the population standard deviation, this is shown by sigma, the population standard deviation. It is standard deviation of the population divided by square root n. But since we don't know the population standard deviation, we take the standard deviation of our sample, and then we divide it to the square root n, to the square root of n. This standard error of the mean provides a measure of the precision of our estimate. It gives us information about the precision of our estimate. So if I ask you in the exam, what is a standard error? Standard error, you have to be able to tell me that it is standard deviation divided by square root n. And what is its use? It is giving us an information about the variation in our sample. Is it how precise we made the measurement? Is it precise or not? Imprecise or precise? Of course, if you have a high, if you look to the formula, if you have a high sample size, if the n increases, the standard error of the mean will be small. And that means it is a precise measurement. If you, out of 420 students, if you sample 20, that means your sample size is a little bit low. Then there will be a higher error rate, of course, and it will not be precise, it's imprecise. If you make your measurement in 100 students, that will be much more precise. Okay, therefore, we try to increase the sample size as many as possible to decrease our error in measurement. When we present in our papers, when we present it I will show you one study. Where was it? Here, this one. Okay, not this one here. Yeah, here. PubMed. When we present it in our papers, we usually give the standard deviations we give the standard deviations, plus minus standard mean plus minus something. Okay, this page I don't have standard deviation, but I showed you before. And if you look to the scientific papers, you will see mostly standard deviations are given in a paper. So also you, when you do your analysis of your projects, you have to present the standard deviations, not the standard error of the mean. The standard error of the mean is only presented if you want to, if you are interested in the precision of your data. If you want to give some technical information, you give the standard error of the mean. Otherwise, you always present in your scientific papers, you present the standard deviation. This standard error of the mean is, of course, for the numerical data, such as weight, height, blood pressure, blood sodium, potassium levels. But sometimes we have a categorical measurement, like the possibility of having a disease or not. Then you have a proportion. Also in a proportion, it's possible to calculate the standard error of the proportion. Also, this formula I want you to memorize. If you want to calculate the standard error of a proportion, then you take this formula. You multiply the possibility of the event multiplied by the possibility of not having the event, 1 minus possibility, divided by n, and take the square root of it. This is how you calculate the standard error of the proportion. So in summary, we in sampling we have two issues. One is the sample size, how many people. Where is my PowerPoint? One, in sampling we have two issues. One is the amount of the sample, how many people we will have, and the second is how we are going to sample, the method of sampling, how we are going to. And that, when we discuss the how, then there are many methods such as random sampling, convenience sampling, quota sampling, systematic sampling, snowball, square root, and even more than that. But the most important issue in sampling is it has to be representative of the sample, and it has to be random, if possible, whenever possible, random. Which of these samples is not random? Convenience sample, of course, is not random. Quota sampling is also not random, that you already can guess. So if I ask in the exam, which of these samples is not random, you should be able to answer that question correctly. Okay, Dr. Zaman. The time is up for having a break. I can stop here. Let us have a 10 minutes break.
Okay.
Shall we?
Okay.
Then we will discuss confidence intervals. Okay?
Okay.
Okay, sir.
See you after 10 minutes. About confidence intervals. Before mentioning about the confidence intervals, let me tell you that during this course, we don't expect you to memorize too many formulas, but some basic formulas you must know. The formulas you need to know, some formula. You need to know is the standard deviation, the formula of the standard deviation. Standard deviation, shown with the small s. Can you help me to write down the formula for the standard deviation? How was it?
Sir,
was a
we should
sigma.
do square root of variance.
Yeah, very good, very good. Okay, let me say
X.
what is the formula of the variance then? Square root of the standard deviation. It was x, yes, minus
X minus m
m
mu
or x bar, yes, mu
and square
square divided
and
by,
divided by n.
yeah, n or n minus 1.
N minus 1.
Yeah, this is the formula for the standard deviation or variance. This is for variance. If you take the square root of variance, it will be standard deviation. And last session we discussed about the standard error of the mean. It was also a very simple formula. Standard deviation divided by square root n. This is our formula for the standard error of the mean. And we have another formula you need to know, which I will tell you this session. It is the confidence interval, the CI, CI, confidence interval. Confidence interval. The formula for the confidence interval is the mean x bar, mean, plus minus, if it is 95% confidence interval, 95%, then mean plus minus 1.96 multiplied by standard deviation. So this is today's formula. There are only 3 formulas you have to memorize. I will mention about other formulas, but I will not ask you in the exam. For example, I have shown you the formula for the normal distribution. I will mention about the formula for the t-test or for the chi-square test. But these 3 you have to know by heart.
Mister,
Yes.
in the last lesson you said, like a minute ago, you said that standard error proportion formula you will ask. So you weren't gonna ask?
Yeah, standard error of the mean, it's for the mean, and standard error of the mean of the population also, of course. If I ask standard error of the population is, you have to be competent also. Standard error of the mean or population standard error, you have to know standard error. Standard error you have to know. So if it is a population, it is just p multiplied by p1 minus p divided by n. If it is the mean, it is standard deviation divided by standard error of the mean. But first, you have to understand what is the confidence interval. What is this? More important is possibly to understand what is a standard the confidence interval, or the confidence interval calculated from using the standard error of the mean. To describe it to you, let us assume you had a population. You had a population, n, and from this population you made a sampling. You sampled n people. Sample n. You sampled n people, and you made a calculation. What you calculated? You calculate the, let's say you calculated the weight of the people. This is the weight of the people. What kind of variable is the weight? It's a numerical variable. You made a numerical calculation. So if it is a numerical calculation, then when we describe it, we give its mean and standard deviation. whenever possible. If it is not normally distributed, if it is skewed, of course, we prefer to give the median instead of the mean. Descriptive statistics. Let us see what is the mean I have measured here. The mean here is 51.3, okay? And the standard deviation is 15. So if I have a mean, my mean is 51, 51.3, let's say, okay? 51.3. And you go, you measure from your sample, and you tell me that, Professor, the weight of my population is 51. And then I can ask you, okay, my dear, you did this measurement, but you made it from a sample. You didn't measure every individual in the population. Therefore, there is an error. There is a possible error in your measurement, sampling error. It's not 100% the same as it is in the population, right? You're aware of this? If I go and do another sample, let's say you took n people and one, I take another and two people, another 100 people. You sampled 100 people. I sample another 100 people. It will be a little bit different than that. It will not be 100% the same, right? Then I can ask you, you may be asked, okay, you measured it 51.3, but if I go and measure it again, will it be 51.3? Of course, it will not be 100% the same. Then you are forced to mention the confidence interval, your confidence of your measurement. How much confident are you that your means are in between certain values? If I measure it with the SPSS, okay, if I measure it with the SPSS, I can calculate the confidence interval by here, explore weight. Should give me the confidence intervals, I think. Let us see. Okay, you see, it gives me the mean 51. Microphone off, please. And it gives me a 95%. We usually use the 95% confidence interval, and which is here in this case 49.5 and 53.0. So I ask you the 95% confidence interval, which is now here between 49.5 and 53.0. 49.5 and 53.0. What does this mean now? Kilogram, of course, again. It means if you have measured the mean weight of your sample, which you have taken from the population, and it is you describe me, you report to me that it is 51, and I ask you, my dear, you have calculated your sample mean from a population, but you did a sampling. It is not 100% correct. What if I go and I do the same measurement? How much precision you have? How much confident are you that your values lie in between certain values? Then you tell me, Professor, I am 95% confident that my values will be between 49.5 and 53.0. So that means go and do the same experiment yourself. If you go and make your experiment 100 times, in 95 of these 100 measurements, the values will be, the mean weight will be between 49.5 and 53.0. That's how we describe the 95% confidence interval, or in general, the confidence interval. And if you ask me, how we calculated this, how we found this 49, it is very easy. This is the formula. The mean, we take the mean is 95, plus and minus, first minus, mean minus means 51.3 minus standard error of the mean. Standard error of the mean is calculated here, 0.891. So 0.891 multiplied by 1.96. Why 1.96? Why by SEM, standard error of the mean? Why 1.96? You know the reason?
95%.
Yeah, because of the normal distribution. This is of course for normal distribution. Huh? If you have using a normal distribution, your multiplier is 1.96. If you have the t distribution, you have to go and check for the t value. But if you remember my session with the t distribution, you will understand that if sample size is high in the t, like 50 people, the multiplier of the t is almost the same as the normal distribution. So if you have a normal distribution, 95% of the cases were between here. This is 95%. 95% of the cases were between minus 1.96 and plus 1.96, or approximately 2 standard deviations. Standard deviations. Mean plus, this is mean minus, this is mean plus, of course. Mean plus, and here we have the mean. Okay. So if I ask you to calculate this, you will do what? 51.3 multiply plus 1.96 multiplied by standard error of the mean. And how we calculated the standard, this is 0.891. This is standard deviation divided by square root n. So standard deviation is here 15. 15 divided by n is 295. Square root 295. I will not ask you in the exam, don't worry to make the calculation, but I will ask you how it is calculated. Although it seems here very complicated, too many numbers, you already know these numbers, you see. You don't know maybe about skewness and kurtosis right now, but you know all these other things. The mean, how is mean calculated? You know it. How is standard error calculated? Standard error of the mean, you know it. Because if you know the variance, 234, you take the square root of variance, it is 15. If you divide 15 by square root n, 15 divided by square root 295, you will find the standard error. You want me to calculate this? No, I don't think it's necessary. Do you think it's necessary to calculate it? Do you want me to do this calculation? What is the square root of 295? 295. Take the square root. Where is square root here? 17.1. 17.1. Okay, so 0.89 divided by 17.89 divided by 70. This is 0.0005. So you add and you subtract. You multiply it by 1.96, of course. Okay, multiplied by 1.96. This is what you have now. And this number, you have to subtract and or add to your mean. So if you have normal distribution, which I will ask you in the exam, always normal distribution, most of the time, because t distribution, you have to go and find the t value. This I didn't show how to do it, because the computer does it automatically. It calculates it automatically. But if you don't have the computer, you have to do it by hand or look up from the tables, which we didn't teach to you, because I don't think it's necessary. But you have to know the formula with the 1.96. If I ask you, okay, you calculated and you have given me the 95% confidence interval. If I ask you what is the 99% confidence interval, what can you guess what would be the formula for the 99% confidence interval? If anybody can guess it, he or she should receive an extra mark. Let me show you the normal distribution here. This is our the values for our normal distribution. Okay, so for a 95% confidence interval, the formula was x bar or mean plus minus 1.96 multiplied by, this is standard error of the mean, sorry, not standard deviation. So multiplied by standard error of the mean. This is our formula. The multiplier is 1.96. If I have 99% confidence interval, what would be the multiplier? What would be the formula? Anybody
Instead of
remembers? You can look from the
2.58.
Yeah, it would be 2.58. Okay. Yeah, you deserve an extra mark.
Thank you.
You have to memorize during the oral exam, okay? Are you attending the oral exam? Yeah.
Okay, Mr. I'll go ahead.
Okay. So, I have to show you this confidence interval also in the exams in research. Yeah, I have described how we interpret the confidence interval. The confidence interval, as the name implies, as the name says, the confidence interval tells how much confidence you have in your measurement, how much precise your measurement is. And related to that, we have to also know about the degrees of freedom. In a numerical measurement, the degrees of freedom is usually expressed as n-1, n-1, because if you have, for example, this degree of freedom, just briefly mention it, okay? Then I will show you one study result, and then we will finish this session. Degree of freedom, df. df is n-1. Why it is n-1? Because let's say you have 3 measurements, 1, 2, 3 measurements. And the first, we know that the sum, okay? The first person has a value of 10. The second person has a value of 15. And the third person, we don't know. But we know the sum. We know that the sum is 30, let's say. Okay. If we know that the sum is 30, the first person can take any number, second person can take any number. But if I know the first 2, the third person is not free anymore. The degree of freedom is n-1. If n is 3, the degree of freedom will be 2, n-1, because one person is free. Yeah? The 2 persons are free to take any number, but the third person must be 5 in this example. He is not free anymore. So one is always not free anymore. There are other two, the remaining, how many they are free to take any number. Therefore, this in biostatistics, this n-1, the degree of freedom has been introduced, and it is used in all calculations. If you have a large sample size, of course, dividing something by 1,000, if you have an n 1,000, dividing to 1,000 or 999 doesn't matter much if you take n or n-1. But if you have a small sample size, let's say your sample is 10, dividing to 10 or dividing to n-1, that n-1, 9 would be make a very much difference. Here, if you have a large sample size, the n-1, the degree of freedom might not be that important. But if you have a small sample size, of course, taking the minus subtracting by 1 is very important. Bootstrapping, you can read from the book. That's not so much important. It's a method used in biostatistics, but we will not use it. We will not discuss it. Okay, so here I have before closing this session, one example from the PubMed, from a scientific study. What is it about? Continuous subcutaneous insulin infusion versus multiple daily injection regimes in children and young people at diagnosis of type 1 diabetes. As you understand from the title, they have made a study in children, and they measured blood glucose, most probably, or insulin levels, or hemoglobin A1C, I don't know. And they have given continuous subcutaneous insulin. This is a treatment method, a recent treatment method in diabetes. You have a pump which gives subcutaneous insulin, and the old method is daily injections. The patient receives daily injections, like some 2 injections a day or more than 2 multiple injections in a day. So let's see the results. I just want you to go to the results here. See the results here. They have 294 participants, and out of these, 293 included in detention in the analysis. At 12 months, the mean hemoglobin A1C, you see, hemoglobin A1C they calculated. Hemoglobin A1C, you as future medical doctors, you should know what it is. It is, as Dr. Azamat mentioned, the normal value was 5.5, I think. Or for diagnosing diabetes, the threshold is 6.5. So in a normal person, you should not have hemoglobin, glycolized hemoglobin, too much glycolized hemoglobin. But if you have high blood glucose, the hemoglobin A1C will increase. So they give them the difference between the two groups. One group is receiving CSI, continuous subcutaneous injection, and the other group is receiving starting doses of CSI, MDI. Okay, MDI was for multiple injections or what? Anyways, 2 groups. In one group, you have the mean 60.9. In the other group, you have the mean 58.5. So there is a difference, the difference of 2.5 millimole per mole. If you present this 2.5 to your audiences, they have the right to ask you, okay, you made a study, you didn't investigate all the population. You take a sample of 293 people. and you calculated that the difference is 2.4. But how much confidence do you have in this? If I go and I do the same measurement, will it be 2.4 or can it be something else? And here is the confidence interval. The authors give a confidence interval and they mention that it can be when you go and you do the same measurement in 100 times. In 95 of these 100 measurements, it can be, the difference can be 0.2, minus 0.2, sorry, minus 0.2, or up to 5.3. What do you understand from this confidence interval? They measured it 2.4, but they report if you go and you do the same measurement, you measure the difference.
Sir, is it the 95%? It's like the limitation.
Yeah, this is 95% confidence interval. The 95% confidence interval.
Okay, the minimum is 0 minus 0.4 and maximum is 5.3.
Yeah. So is it large? Is it small? Is it okay to you? What does it imply to you? What do you understand from it?
Sir, can I say the 2.4 is the mean and the...
Yeah, but it is the mean difference. Be careful. Be careful. It is the mean difference. The difference. The difference is 2.4. It means that if you have a difference 2.4, this CSI group, which has a mean of 60, a value of 60, and the MDI group, which has a value of 58, it means that this is higher, of course, isn't it? The difference is 2.4. But if you see the confidence interval, you should be able to tell me something else. The difference, if I go and I calculate the difference, if I do it 100 times, the difference is not always positive. You see, here it is positive. This group, this MDI is larger. But if you give me the confidence interval and I see the confidence interval, I easily understand that the difference can sometimes be also 0 or it can be even negative. The difference being negative means that sometimes this group, the MDI group, may be larger. Isn't it what you understand from this confidence interval? If the confidence interval is between minus something and plus 5, it means sometimes out of these 100 measurements, sometimes this CSI group may be larger, or even sometimes the MDI group can be larger, so that I will have a negative confidence interval. You see, therefore, they reported a p-value which is 0.09, a p-value of the p-value usually the arbitrary acceptances, a p-value below 0.05 means significant difference. You know why this is 0.05? Because of the normal distribution, because 95% are here, 95%, and 5%, 2.5, and 2.5. These are the abnormal. These are the above and below the 95%. So therefore, a p-value below 0.05, we usually regard as significant. If the p-value as it is here, above 0.05, I understand that the confidence interval of the difference is including 0. That means there is no difference. The p-value is large. You see? So the confidence interval is very useful entity, a very useful indicator for me to understand whether there is a significant difference or not. If I have a confidence interval of the difference, like here, which is including 0, I will easily understand that there is no significant difference between the CSI and the MDI groups concerning the mean values here. Sometimes the CSI may be larger, most of the time the CSI is larger, but even it is possible that I have a negative difference, negative mean difference. Yes. So that's how we interpret the confidence intervals. The confidence interval, if it is large is subjective, of course. There is no rule for large. If it is large confidence interval, it means you don't have a precise measurement. If you have a precise estimate, you should have a small confidence interval. Is this confidence interval large or small? That's there's no mathematical rule for this. This is a clinical decision you have to take. If you are a clinician and you look to the data, you will be able to tell it is large or not. If it is large, it means there is no precise measurement. If it is small, the confidence interval, it means you have a narrow confidence interval, means you have a precise estimate. And if the confidence interval of the difference includes 0, as it was in this example here, if the confidence interval of the difference includes 0, it has negative and positive values in it. It means this difference is not significant. It can be sometimes positive, the difference, and sometimes negative. That means the p-value is larger than, the p-value is larger than 0.05. Here it is 0.09. Cool. Yeah, I know that today we discussed two issues, which is too much theory maybe, but they are very important, sorry, for you to understand the future classes. So please go and read them once more, and if you want, we may discuss it. Try to solve also the examples here. And if you have questions, we can discuss it next time.
Thank you, Mr.
Okay. Dr. Azamat, is there anything missing I should mention, or can I stop here?
No.
I always ask Dr. Azamat. He's a good friend supporting me. Yeah. There is one video I should show you. Sorry, before closing, before letting you go. Where is it? Yeah. This is one of my courses I recorded before earlier about sampling. This guy here, he is a tradesman buying and selling nuts. As you see here, there are a lot of sacks with nuts, and he is holding something, a pipe, something like a pipe, which he's pushing into the nuts. Let's see what he's doing. Let's see what he's doing. You see here, it has some openings, but it has a mechanism whereby he can close these openings. You push it into, it doesn't show it very well. You see how it describes? If you take it by hand, he says, you just sample from the top. You just sample from the top. You don't know the quality of the nuts deep in the middle or in the bottom of the. If you push the pipe in, you will sample. See, now he sampled from the top, from the middle, and from the bottom. He sampled from all parts. Now he can weigh, he can check the quality of these nuts. If they are in a certain quality, he can assume that all the population of nuts has the same quality. So this just briefly, because before closing, I wanted to show you about the sampling. It is in real life, it is everywhere. The sampling is always applied in our daily life. Okay, thank you for being with me. See you next time.
Thank you, Professor.
Bye bye.
Sir,
Thank
what
you,
time is
Mr.
the test?
Yes,
Dr.
excellent.
Azamat, you respond. Maybe right now or after half an hour. Shall we start after half an hour, Dr. Azamat? Are the students available?
I'm available.
Okay, let me
Okay.
open the timetable.
I can take it now if you don't mind.
Yes, me too, sir. Even Dinara.
Okay, but you have to give me 10 minutes at least,
Okay.
15 minutes
Okay.
break for me.
Okay.
Okay,
No problem.
then after 50 minutes, Dr. Zakaria.
Okay, after 15 minutes we can start if you want. Yeah.
Okay. I will send the link.
You can send me a new link. Yeah, thank you.
Yes. See you.
So we will take it with old list, right?
Yes, according to the list that he sent me.
Okay. Thank you.